So, good morning, guys. I am Bhupendra here, and I am giving you the presentation on the wine quality check by using the machine learning algorithms. I have done this project under the supervision of Ms. Deepti Sarawat ma'am, and let's start this. Then here is the index in which there is an acknowledgement, introduction about the wine quality check, types of wines, problem statement, objectives, proposed methodology, technology used, data description, description of the project. Then after description of the project, I will tell you about the demonstration of the practical implementation. Then after I will tell you about the applications and references. So first of all, acknowledgement. I would like to express my special thanks of gratitude to my teacher, Ms. Deepti Sarawat, who gave me the golden opportunity to do this wonderful project, wine quality check, which also helped me in doing a lot of research, and I came to know about so many new things. Uh, I am really thankful to them. Then here it comes to the introduction to the wine quality check. Here is a little introduction about what my topic is all about. So it is about the wine quality check. So what is wine? Wine is a beverage made from the fermented grape and other fruit juices with a lower amount of the alcohol content. The quality of wine is generally checked by the machines, and in some factories it is generally checked by the humans. The wine itself contains so many parameters like the fixed acidity, volatile acidity, citric acid, residual sugar, pH, sulfates, alcohol, and quality. Then I will tell you about some colors of the wines, and the actual color of the wine is the violet. But for some of the wines, like mature wines, it has the red color. Some older wines, it has the brown color. Then for some greenish white color in the purple grapes, and there is a red flesh which also produces the red juice, and it is also included in the wine. Then here are some types of wines. Like actually, there are so many varieties in the wines, but I am not here to tell you about those varieties. I am just telling you some important types, which are the red wine, white wine, rose wine, fruit wine, and basically these all wines are generally taken from the grapes. So here comes our the problem statement. So in the recent time in the industries, the basic understanding of the demands of the wine safety testing must be a complex problem for the workers, as they are not able to find manually which wine has the good quality and which wine has the bad quality. So in this project, we predict and provide the ideal solution for the analysis of the wines. It also checks whether the wine is in the good quality or bad quality, so that user can take it and save their lives from any disease. So, what is the objective of this project? Our main objective is to find whether the quality of the wine is good or bad by using the machine learning algorithms through the Python programming. There is a larger data set is considered, and the wine quality is modeled to analyze the quality by using the different attributes, as there are almost about 12 attributes. We have applied so many ML algorithms and also compared the accuracy between these. At the end, we also draw the ROC curve between the predicted values and the actual values. Then what is the proposed methodology of this? It gives us the insights of the dependency of the target variables to the independent variables, or we also say that the independent variables are generally known as the feature variables. The dependent variable here is the quality, and the independent variable are alcohol, sulfur, chloride, etc. While working on the dataset, we face so many problems like removing the null values and checking the accuracy and precision, F1 score, and so on. So here comes the technology used. I have used the Python programming language, and in the Python programming language there are so many libraries like pandas, numpy, sklearn, and then we have the machine learning algorithms, which are the SVM, random forest, decision tree, naive bayes, and so many. Actually, machine learning is also classified in the supervised machine learning and unsupervised machine learning. In the supervised machine learning, we have the SVM and Naive-Bayes and random forests, but in the unsupervised, we have the clusters type algorithms. Then I have used the Jupyter notebook, in which I have implemented all these Python programming language and algorithms. So here comes about the data description. The dataset contains of the chemical description of about 1600 vines. Basically, it has 1600 rows and about 12 columns. And this dataset is being taken from the Kaggle. Kaggle is the site where you can download any type of data for your project and for any other work, and it is free. So here are the 11 columns, which are the feature variables, which are pH, density, alcohol, fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, and free sulfur dioxide, total sulfur dioxide, and sulfate. And one column is the target variable, which is the quality. This is the dependent variable, and these are all the independent variables. So here comes about the description of these attributes. The pH is to measure the ripeness. Density is the density in gram per centimeter cube. Alcohol is being calculated by volume of the alcohol in percentage. Fixed acidity is the impart sourness and resist microbial infection measured in number of grams of tartaric acid per dm3. Volatile acidity is the number of grams of acetic acid per dm3 of wine. Citric acid is the number of grams of citric acid per dm3 of wine. Residual sugar, then chlorides, then free sulfur dioxide, free sulfide, potassium, acetic acid. These are all the terms which are come in the chemistry. Uh, I think you already know about these terms. Then here is the after this there is a description of the project, what I have done in my project. So let's get started. So first of all, the first step comes here, the importing the dataset. To read and import the dataset in the project, we first have to import the necessary libraries. Necessary libraries like sklearn, pandas, matplotlib. So what is pandas? Pandas is a software library written for the Python programming language for the data manipulation and analysis. Then the matplotlib. Matplotlib is a plotting library for the Python programming language. Basically, matplotlib is used to plot different types of graphs like bar graph, pie chart, and scatter plot graph. Then after importing these such libraries, we read the dataset by using the read function in the Python. So here comes is the data processing and cleaning part. For cleaning the data, I just check the null values present in the dataset, and after detecting the null values, I removed it by the use of the replace function in the Python. You can also use the fill na function to clear the null values. But for clearing that, I will tell you what I have done to remove those null values in my implementation part. So here comes what is the replace function used for. Then this function is used to replace a particular value from the column, and we can also change the values of the different by a single value by using this function. Different columns here. Then I use the one hot encoding method to add a column for the quality, and that column is the quality good quality column. So what one hot encoding done is, one hot encoding is essentially the representation of the categorical variables as the binary vectors. Then further, then in the pre-processing and cleaning the data, at the end I standardize the data. What does here the standardization means? Standardizing the data means that it will transform the data so that distribution will have a mean of 0 and a standard deviation of 1. It's important to standardize your data in order to equalize the range of the data. Basically, if I take an example of height and pounds, if these are the two attributes, one is height and one is pound, then they both have the different types of data in this. Suppose if we uh, predict any value, then maybe it is possible that it exceeds the range of the pounds if we and exceeds the range of the height. Suppose if there is not a person in here which has the height of around 12. I have a height around 5'11", then I don't think that there is a person in this house who has a height of around 12. Then to standardize these types of data, we use the standard scalar function, so that it will gives the data in the range of -1 to 1, or -1 to 0, or -2 to 1. I will show you in my implementation part what I have done. Then breaking the dataset into the feature and the target variables. So we have the total about 12 attributes, in which 11 are the feature variables, and one is the output, which and the target variable. We store the feature variables as x and the target variable as y. In the x, we have the fixed acidity and volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, and alcohol. Then we have the target variable, which has the good quality. Then next step comes here, the splitting the data in x, and the splitting the x and y into the training and testing of the data. So for splitting the data, we use the sklearn library, and from that library we import the model selection and use the function train test split. So what is the sklearn library here? Sklearn is a free machine learning library for the Python. It features various algorithms like SVM, random forest, and k-neighbors. K-neighbors is also a type of the algorithm of the machine learning. So what is the training set and testing set here? A subset to train a model is the training set. Like if we split the x in the training set, x and y in the training set, then the here are the variables which come, which are the x train and y train. Then test set, a subset to test the trained model, is the test set. So here is the x test and y test. Then here is a little diagram of the training set and testing set. Suppose here this is the about 100% data. Then if we split the data into the training and testing set, that this part contains the training set, which is around maybe 80% or 90%, and testing data is very small. Maybe it is 10% to 20%. It is up to you. Which size would you like? Then we apply the different classification models. I have used three different types of the classification in my project, which is the SVM algorithm, decision tree classifier algorithm, random forest classifier algorithm. In the next slide, I will tell you about these algorithms and what are they. And here is the SVM algorithm. SVM algorithm is a machine learning algorithm, and this algorithm comes under the category of the supervised machine learning. To use the SVM algorithm, we have to first import the SVM from the sklearn library. SVM is basically a class, and from the SVM we import the SVC function. After doing this method, we generally model the data, and after modeling it, we train the data by using the fitting function. In the fit function, we pass two variables with two parameters, x train and y train, and after that, we predict the values and predict the value. We predict the x test value. We use the predict function for that. Then here comes the decision tree classifier algorithm. It is also a supervised machine learning. In the decision tree, we use the tree classifier algorithm is used. We have to first import the tree class from the sklearn library, and then import the decision tree classifier function. Then we model it and train it. In the random forest classifier, it is also a category of the supervised machine learning. And to use this, we have to first import the ensemble class from the sklearn library, and from that we have to import the random forest classifier function. And after modeling it, we fit the function, and then we predict the values of the x test. Now here is the comparison of the good quality and the bad quality vines of all the three models, like SVM algorithm, decision tree classifier algorithm, and random forest classifier algorithm. They're basically these are the pie charts. The orange part shows us the good quality, and the blue part shows us the bad quality, which means in the data set there are so many vines which are of bad quality. Then here you can see in the SVM algorithm, bad quality is about 88%, and good quality is about 12%. Decision tree classifier, bad quality is all about 93% and good quality is 7%. And in the random forest classifier algorithm, bad quality is about 92% and good quality is about 8%. Here is the comparison of the evaluation metrics of the different model, which is the precision, recall, and F1 score. In the SVM algorithm, you can see precision is 0.88, recall is 0.99, and F1 score is 0.93. So, what is basically a precision, recall, and F1 score means here? Precision here means it is the true positive. There is a confusion matrix which has the four parameters like the true positive, true negative, false positive, and false negative. So precision is the there is a formula of the precision which is the it is the ratio of the true positive about the total number of the positives, which are the true positive and false positive. And recall is the ratio of the true positive to the total number of actual positive actual values like true positive and false negative. And then here comes the F1 score. So what does the F1 score means here? F1 score is generally average of the precision and recall. So you can see that if precision is 0.8 and recall is 0.99, if F1 score is the average of these two, then 0.93 comes under these two values. So here is the SVM algorithm and decision tree classifier, evaluation matrix, and the random forest classifier uh, evaluation matrix. Then there is a comparison of the accuracy of the different ML models. So SVM is about 92%. SVM is about 85%. Decision tree classifier is about 93%, and random forest is about 96 or 97%. Basically, I have separated these colors. If I have used the blue color for the SVM and red color for the decision tree and random forest for green color for the random forest. Then here it comes for the comparison of the predicted values of all the three models. Predicted values means 0 and 1, which is predicted by the X test by using the predict function. So in I have used the scatter plot graph. In the SVM algorithm, you can see that in it has predicted so many bad quality wines, and some of are the good quality, which are one. It is generally in the good quality there are only two values, 0 or 1. If it is 0, then it is a bad quality. If it is 1, then it's a good quality. So there no such value lies between the 0 and 1. So it is a blank space. Then decision tree classifier algorithm, random forest classifier. These are the graphs for that. Then here we compare the confusion matrix of all the three ML models. This is the confusion matrix of all the three models. Uh, Here is on the y-axis I have taken the actual value, and on the x-axis I have taken the predicted value. And here is a comparison of the ROC curve of all the three models, of all the three ML models. First is the SVM algorithm, second is the decision tree, and third is the random forest. So here I have plotted the ROC curve of all these algorithms. So here comes about the applications. What means which in which area this product is useful for. These results will be used by the wine manufacturers companies to improve the quality of the future wines. It is the certification bodies can also use the result for the quality control. Results can be used to make the wine selection guides for wine magazines, and the results can be used by the consumers for the wine selection. Then we have the references. I have used these three references to create my project. I have shared you this PPT, then you can go through these. And that's the end of my presentation.